Alright, we are going to be solving the question above. The question says a flitched beam consists of a wooden joist 10 cm wide and 20 cm deep, strengthened by two steel plates 10 mm thick and 20 cm deep as shown. Alright, so you can see the diagram below. We have two steel plates and a wooden joist. So the thickness of the steel is 10 mm, right? And you know 10 mm is equals to 1 centimeter. So that is why we have 1 centimeter here, 1 centimeter here. And the wideness of the wood is given to us to be what? 10 centimeter. The depth of the steel and the depth of the wood is same. They are what? 20 centimeter. So here is the given data. So we have the base of the steel, we have the depth of the steel, we have the base of the wood, and then we have the numbers of the plate. The numbers of the steel plate given to us is just 2. So we have 2 steel plates, and the depth of the wood is 20, and the maximum stress of the wood is 7 Newton per mm square. Here is the modulus of the steel, and here is the modulus of what? Of wood. All right. So for us to start the solution of this question, we are going to start with the moment of the steel. Moment of the steel plate about the neutral axis. Moment of inertia of steel plate. All right, about the neutral axis. All right, so this will be I subscript S, which will be going to be equals to what? We know that the steel plate is just in form of a rectangle, so it's going to be the base of the steel, then the depth of the steel, all cubed, divided by what? By 12. All right, and you are going to recall that the base of the steel here is equals to 2t. So the base of the steel is equals to 2t. So we can therefore write this formula to be 2t. Then the depth of the steel all over what? All over 12. So if you substitute now, I'm going to have 2 multiplied by the thickness is 1, multiplied by the depth of the steel is 20. So we're going to have 20 cubed here, then divided by 12. All right, so if you press that in your calculator, you are going to have 1333 .33 cm to the power of what? Of 4. All right, so if you can convert this to be in mm. So it's going to be 133.33 times 10 to the power of 4 mm. 4. All right. So the next one is the moment of inertia of the wooden joist. Moment of inertia of wooden joist about the neutral axis. All right. So yeah, this is I subscript W, which is going to be B subscript W, then D subscript W cube all over what? All over 12, right? So if you substitute there, we are going to have the base of the wood is 10, right? So we are going to have 10 multiplied by the depth of the wood is 20, right? Yeah, 20. So I'm going to have 20 cubed divided by 12. All right. So if you press that in your calculator carefully, you are going to have this to be 6,606 point what? 0.66 cm to power 4. So if you convert that to mm, you are going to have 6666.66 multiplied by 10 to the power of 4 mm to the power of 4. All right. So the next thing we are going to calculate here is the modular ratio. All right. You know it is denoted with what? M. All right. We know that modular ratio is equals to the young modulus of steel all over the young modulus of wood. So if you substitute, you are going to have 2 multiplied by 10 to the power of 5 divided by 1 times 10 to the power of 4. So this is going to give us 20. All right. So for us to calculate the moment of the composite section, the moment of the composite section is also the moment of inertia of the composite section is also the moment of the equivalent moment from our derivation. You know, we derived that, we said that our moment of inertia equivalent. All right, so this is equals to the modular ratio multiplied by the moment of inertia of steel plus the moment of inertia of wood. All right, so if you substitute that, we are going to have 20 multiplied by what? 20 multiplied by the moment of inertia of steel, that is 133.3 times 10 to the power of 4 plus this. So we are going to have 6666.66 times 10 to the power of 4. All right. So if you press this all together, you are going to have 30,000. No, you are going to have 33,303 point what? 0.2 times 10 to the power of 4 mm power 4. All right. So this is also moment of inertial equivalent is also known as what? Is also the moment of the composite section. All right. So the second question there says we should find the what? We should find the corresponding stress. All right. So for us to do that, you are going to recall we said the load, the strain in the steel is equals to the strain in the wood, right? And there we said that this is the formula for strain, right? That is the stress in this steel all over the modulus of elasticity in steel is equals to the stress in the wood all over the modulus of elasticity in the wood. And where we make this the subject, to make that the subject, we are going to have stress in the steel to be equals to modulus of steel all over the modulus of what? Of wood multiplied by what? The stress in the wood. And we know that the ratio of this is what? M, right? Which is our modular ratio. So we can therefore say that the stress there is going to be M multiplied by what? The stress in the wood. So if you substitute now, we are going to have 20 multiplied by what? 20 multiplied by 7. So 20 multiplied by 7, that is 140. So it shows that our answer here is going to be 140 Newton per what? Per mm square. All right. So let me write it here. So this is going to be Newton per mm square. So here is the solution to the above question. I believe we understand this. So if today is your first time coming across our content, don't forget to hit the subscribe button and the notification bell so that each time we upload video like this, you'll be the first to receive the notification. And don't forget to join our membership for premium content like this. There you are going to have access to ask us questions on other related topic or any other topics in engineering. We got you covered. Stay tuned for more interesting content. Thanks.